Plumbing and fuel systems, not our problem. Hey, good morning. This is Joel Walsman, CEO and Master Electrician of Jefferson Electric. With me today, I've got Tim Shackleton. Tim is a member, vital member, full-time member of our Electric Pro Academy team and a project manager, in fact. And Tim and his wife recently bought an extensive fixer-upper house, and we're gonna be reviewing your inspection report and exactly the issues that were present, things that we did to overcome those issues, and taking a deep dive on the electrical pages of the inspection report, associated codes, best practices. I'll make a real quick comment here. Electricians get confused and wrapped around the axle all day long. If you've ever been on an electrical forum, you see lots of debate and banter back and forth. And part of that is because of the confusion between codes, various code cycles, best practices, local interpretations, and enforcement of those codes and best practices. And so you've got 7 electricians in the room, you've got 8 opinions guaranteed. The code is that complex, and there is, even though it's a technical document, there is that much latitude for interpretation. Why is this video important? Well, let me tell you what. We encounter inspection reports all the time. We work with probably 20 to 30 different realtors, and electrical issues are continuously and ubiquitously present. And so we're gonna, if you're a homeowner, buying or selling a home, if you're a home inspector, if you're an electrician, if you're anybody related to the transaction of a residential property, this video is gonna help anchor the electrical portion of the inspection report so that you can understand common codes and violations and associated pricing, best practices for these types of repairs. Tim, tell us a little bit about your house, how you and your wife came to find it, choose to live in a transitional neighborhood. What does all this look like?
Yeah, so my wife is actually a real estate agent. She was looking for a friend for a low-cost 4-bedroom house in the Indianapolis area. Not very easy to come by. She actually found, when she kind of plugged it into her software, 5 total houses, but one of them happened to be just down the street from us. We were kind of intrigued, kind of confused. We hadn't really taken notice of this house before. We don't think there was a sign in the yard, but kind of jokingly we said we'd walk through it. We didn't have major plans then, but we are expecting in about a month our first child, so we're starting to think about maybe growing and the things we want in a dream long-term house. We were just kind of staying in a smaller 3-bedroom, so we walked through it. We saw tons of potential. It's a 1915 traditional 4-square
So you
basement.
transitioned from a brand new build, first occupants in a brand new build, to a 1915.
Yes, we were really blessed up front too that I was teaching middle school at the time, and so I qualified for a low-income housing program that had just built a number of new homes, and we were able to get in on that. But yeah, now we were looking at kind of a different realm of a rehab house. In some ways a step down. We lost a bathroom, but we gained a bedroom, and now we've got a nice big yard, and we're really excited about all that. So it feels a little exposing to look at the inspection like, oh, we bought this house, but thankfully it was not our fault that the wiring is a little off, and there are maybe some structural issues or some draining or plumbing issues. So I think I can manage as we go through here.
Right. Because what was the duration of the entire rehab? You and your wife totally did everything to this house.
Yeah. So let's see. We closed in the summer, maybe a little before the summer, about March. So it's November now. So it's been about 8 months of a total electrical rewire, a number of structural corrections. We had a landscaping company come out and redo the yard and grade, put a fence in, re-floored, re-drywalled after some demo and restructuring several of the rooms. It's
open concept around the kitchen.
Yeah,
looks really good.
It's been a big project, but we're really thankful for how it's turned out. We think it'll serve us a long time. It gets great light. It's got great character. A couple handmade arches in some of the doorways that we're excited about all those things, and we think the thing I'm most excited for is that it's a circular build, so our kids can run laps and be active. I'm excited for all that.
You're a collegiate athlete, so you want indoor training before school.
Yeah, even during winter months. No, whatever's fun for
That's
them.
great. Well, I'm impressed that you and Liz undertook, tackling a project of this extent as new homeowners. And I think it's fair to say 95% of people who had walked through that house would have ran away terrified, given the heavy lift that was entailed in this project. So let's do our best to walk through photo by photo in a systematic fashion, looking at each of these violations and talking through the codes around them. So photo number 22-1, we've got 2 open splices here in the attic. And you'll see from this photo a couple things. One, the attic insulation is real minimal. So this is not going to be the final equation as far as the attic conditions at the end of this rehab project. But the junction boxes that are meant to contain and house these electrical connections are entirely absent. It's just a wire nut to wire nut connection. And in addition to that, there's no securement on the incoming wires in any way, shape, or form. So these junctions, really the safety concern here is manifold in this situation. And safety concern number 1 is the junction is not properly contained or enclosed. So if there's a failure on these electrical junctions, that heat, that fire, whatever the case may be, that heat incident is not going to be contained. It's going to be exposed to the nearest combustible framing members, wood framing members right here. That splice is literally resting on combustible material. So we've got an optimal situation for a major heat incident. 2, those connections are not in any way protected from future attic insulation. They're not protected from actual accidental incident. Like, obviously an attic is going to be traversed periodically for different types of service purposes and things of that nature. And the one, from a personnel standpoint, personnel are not protected from the risk of shock hazard suitably. The interior conductors are exposed. The insulation on those conductors is lightweight. It's meant to be contained inside of some type of electrical enclosure. If one of those wire nuts comes off, there's no secondary protection. And so the risk of shock to personnel is substantially increased.
And you said that BX wire is externally grounded, right? So is that the most dangerous in this scenario, or are certain wire types more dangerous than others? I know knob and tube's like a thing.
The thing. And your house had plenty of knob and tube.
Oh.
It's not depicted in this photo here, but yeah, good point. So wire types real quick, and the grounding and bonding and continuity, both mechanical and electrical continuity associated with them. Here, this white conductor, this is Romex. That's what you buy off the shelf today at a home supply store, electrical supply. This right here, this is early generation non-metallic cable. We call it snakeskin affectionately. It almost looks like the snake of a skin, and the outer jacket will peel off and literally look like a snake shed its skin in the attic. And then this one over here, this is BX cable. And that cable, to your point, the outer jacket is the grounding path. And so we have a grounded cable in our non-metallic cable. We have an ungrounded cable in our snakeskin, and we have a grounding path which is not being utilized in our BX cable. So in this situation, a metallic junction box would be required in order to connect and ground with a proper fitting the jacket and the grounding conductor on the non-metallic cable.
Okay.
So that we're now electrically and mechanically continuous as far as the ground path. Ground path is required to be continued through every junction box. And so it's actually pretty typical in an older home like yours, anything built from late 1800s all the way through the 1940s, to find 4 types of wiring: the BX, the snakeskin, the Romex, and the knob and tube. So your house is pretty par for the course in that respect, and it was due for some major updates. Over here, next photo, we've got a depiction of a lack of workmanship. See, non-metallic wiring types like this Romex are required to be secured within every 4.5 feet and within 12 inches of every termination. Your house actually got hit with not just poor workmanship over a long period of time, in a transitional neighborhood, but also a wiring theft. At some point, someone broke into this house and stripped elements of both the electrical and plumbing system and looted the copper. There's been substantial efforts in the last, I want to say, 4 to 5 years to really crack down on scrapping copper. An electrical license or an HVAC license plus property addresses are required to prevent this type of looting to a property. So that's really dramatically actually decreased the number of even occupied dwellings that we respond to, where somebody goes on vacation or there's a tenant transition and the house, for rent sign goes out in the front yard, the house is unoccupied. And we're actually responding on a pretty regular basis to houses that have been stripped of their wiring in the basement. Probably $50 to $150 of scrap copper and $3,000 to $4,000 worth of wiring repairs to make that house livable again.
And sorry, just revisiting this, how do you see that? Is it because of the new Romex that you see mixed in there?
Yeah, that's a good question.
Or just cuts?
That's a great question. That's actually going to be real evident in a later photo here.
Great.
All right, more evidence of poor workmanship, wiring not being secured to and closely following the building finish and surface. This one right here, we had a small amount of wiring that was actually properly run through the joist cavity, drilled holes. And unfortunately, when less than, I'm going to say 15 to 20% of the building wiring is in good shape like this, it is difficult to reuse because it's spliced, especially when you have floor plan changes. It's no longer going to the right destination. That outlet has now been relocated with a wall that's been removed, a kitchen that's been redesigned, relaid out. So there really wasn't much usable wiring, even though there was some current wiring. So our decision collectively was to go the direction of a whole house rewire, because there's very little salvageable, undamaged wiring in the house at all. Got some more views here on the tragedy going on in the basement, wiring tragedy, and you'll see that the wiring here has been cut. Why all of it wasn't taken, no idea. This is a beauty right here.
Yeah, it just looks wrong.
So a couple things going here. One, we don't have protection from physical damage. When the wiring drops down the basement wall, like usually in the overhead cavity, non-metallic exposed wiring is going to be permitted by most jurisdictions. But when it drops down the basement wall, it does need to be secured and supported. And our typical approach would be to put that in a PVC conduit when it's on an exterior wall specifically. That PVC is going to weather a lot better on an exterior wall than an electrical metallic tubing, for instance, that's going to have evidence of corrosion slowly over time. And then, so it's not secured, it's not protected. We are missing GFCI protection and wet location on the basement outlets. There's no contention about an unfinished basement being, by code definition and interpretation, a wet location. And so ground fault circuit interrupter protection would be required. And then also, receptacles are required to be secured in place, 300.11 secured in place, affixed, fastened rigidly and solidly to the building structure, and not to, you can't slap that onto a water heater or a furnace, or it's got to be the structure of the building itself.
And not to a random chunk of plywood that is hanging by the wiring. Got it.
Right, and this is one thing that inspectors will actually fairly routinely require, is some kind of vapor gap between ferrous metals, like we see here. This is a steel junction box, that's a ferrous metal, and a damp surface or wet surface. My contention with plywood is that it has an unsuitable lifespan for the installation that's present. And so electrical boxes often will be equipped with bump outs, 1/4 inch bump outs. That creates an air gap on the back of the electrical box. So that's something to look for if you're planning an installation. If you've got an electrical box like this, steel handy box that's really got no weatherproofing capabilities, and it doesn't have those 1/4 inch bump outs, or an enameled surface, or a PVC coating, or something of that nature, it's not rated for your basement walls. It's going to corrode, and you're going to have a moisture condition inside of your electrical box. That's our lean towards PVC in that circumstance. More evidence of what's taking place here. All right, we've got a little beautiful knob and tube going on here. there it is. Gorgeous, more open splicing, beautiful. All this other, down here is PEX. We've got cold water lines, hot water lines. That's a 10-3 cable, Romex cable that's traveling to, I think, what was the dryer location.
Yeah.
That's been rerouted as well. You'll see a lack of GFCI protection. This one actually has been protected. That cable has, it's in an EMT conduit, and that's, I believe, an interior brick wall, is that correct?
Yep.
So that would be one application where that interior wall really shouldn't see much moisture at all. So we've got more beauty shots here. Stripped wire. I love the fact in this photo right here that they've got a really nice green grounding wire net to continue the grounding path for this absolutely horrendous installation. It's hysterical.
And also, in previous videos, you've talked about water or gas lines being near anything. Ventilation, like those are vents there. They're metal. Does that need any consideration at all?
Yeah, at least two considerations. The first one is that metal ducting does present sharp metal edges, and wiring, non-metallic wiring, has to be run in a manner in which it is protected from damage and abrasion. It has to be installed, and all considerations for protection to the physical jacket itself. And yes, during installation thereafter, you want to make sure that it's not at risk or for harm. And then secondarily, the wiring can be run around the ducting, and there's no proximity limitation, but it cannot be run through the ducting. Sometimes, particularly in a wall cavity, the cavity is the duct way itself in some installations, and it's tempting to just cut right through there and take the shortest path to the next wiring destination. If there is to be a fire event at the house and the jacket is inside the airway system, then what's going to happen if that furnace is probably still going to be running and it's going to be distributing the toxic fumes throughout the entire house, creating a more hazardous situation. So,
and that you said just when it's inflamed or when it's like hot? Like if a wire's touching the vent, is that a problem?
No.
Okay.
The jacket's going to have sufficient rating for the temperature. It's only if it's actually failing, cooking, roasting.
Okay.
All right, here we're into the main electrical panel. There is a bunch going on in here. This is busy. Photo number 1 here, 24-1. Code violation I'd like to illuminate is the double tapping of this breaker. See, we've got 2 hot or ungrounded conductors coming into one terminal. And the question around that is the terminal, everything electrical has to be used according to the listing and labeling. What is listing? Listing is literally a list of products that have been tested and certified by a listing laboratory, like Underwriter Laboratories, most famous listing laboratory this side of the Suez Canal.
UL, right?
UL,
Okay.
That's it. You've seen the mark on everything that you purchase, right? They're all over the place. And so this breaker was not listed and tested to have 2 conductors coming into a terminal designed for 1 conductor. That creates a conflict, an inherent code conflict. And the reference there is 110.3b. That is like one of the most ubiquitous codes because it just means everything. Everything has to be not only installed properly, but also used properly. That's what that is. So,
are there any breakers that are supposed to have double tapped wires?
Yeah.
Okay.
Yeah, those breakers do exist. They're not these. So in this in this photo, we've got a smorgasbord of Siemens breakers. We've got a dishwasher breaker, brand discovered and unknown, probably not compatible with this. We've got Cutler hammer. I think we've got a Square D home line there at the bottom. And I guarantee you that this old breaker panel was not listed and labeled to be compatible with these 4 different breaker types. So we've got an inherent code violation there. It would take a little bit of research to prove it beyond the shadow of a doubt, but it's a 99% chance that's an existing issue. All right, this one right here, this outer jacket inside of the box. I think it's a little bit difficult. This might be contentious with some of you electricians out there. I think it's a little bit difficult to argue that that's a code violation. The code does state that there's a minimum when you've got an overall outer jacket on a multi-conductor cable like this. Is 3-conductor cable. We've got a neutral, a ground, and I don't actually see where the hot is going. when you got a 3-conductor cable, minimum 1/4 inch of the outer jacket inside the clamp and the electrical box. And that's so that we're clamped on the outer jacket, and that provides a protective layer to the inner, more susceptible cables. But it's a little bit hard to argue, in my opinion, that an excessive amount of jacket is technically a code violation. I would wholeheartedly agree that it's a violation of best practice, because that becomes really cumbersome. That outer jacket is not nearly as workable. It takes up more physical space in what's already a tight environment where you're looking for every inch that you can find. So most definitely a violation of best practices.
Can I ask a nitpicky question there?
Yeah.
That little paper within the jacket, is that flammable or no? I've noticed it before.
It is waxed paper. Is it flammable? Maybe one of you can answer that question in the comments below. I'm gonna say it has some fire resistant properties, but help me out, bro. All right, in this photo you really can't see it, but neutral wires were doubled or bundled together under the same lug. It comes back to 110.3B. Those terminals on the neutral bar were not rated for more than one neutral conductor. And there's a lot of sensibility in this for those of us who can be tempted from time to time to take a shortcut. What can happen is, particularly, let's say you've got a situation where you've got a number 14 stranded neutral, lots of very small, fine conductors, and you've got a number 10 gauge solid. I'm straw manning the argument a little bit here. But you've got, they're both copper, they're both neutrals, but they're very different proportions. And when that terminal tightens down on 2 dissimilar conductors, you bet your bottom dollar it's going to snug up pretty well to that number 10 gauge neutral conductor, and that 14 gauge, and a couple of those strands might be grabbed, might be holding on, but you're not going to have a solid, full capacity electrical connection. And so what can take place is you can have heating right there at that point where that smaller neutral conductor is really not getting its full capacity. And if that circuit's loaded, if it's a lightly loaded circuit, the issue's probably never going to become evident. But if that circuit's carrying a little bit more, a vacuum cleaner, a space heater, a dishwasher, a microwave, a number of different things that are high draw appliances, then that draw is gonna rat out the weakness, and you're gonna have a loose neutral issue. And we all know what loose neutrals can do. You can literally have arc flash, dramatic electrical failure involving smoke and fire. A loose neutral is about the worst situation that you can have from an electrical perspective.
You talked about that in another video. We'll have to put one of the links in somewhere.
That's it. Okay, now here's something that's interesting that we're going to hit in a subsequent video here. You see on this breaker in particular right there, that's one of the original breakers to that panel, almost guaranteed. And this one's got a fair bit of it too. But there's not just dirt and dust infiltrating this panel because there wasn't a cover on it. There's also a substantial amount of corrosion, and that corrosion can take place on the outside of the surfaces, but it is also taking place, this is not a watertight breaker, it's also taking place inside in the internal mechanisms of the breaker. So a couple thoughts for you here. One, the manufacturers typically will recommend that a breaker gets exercised, how many of us actually do this, to the off position and back on again once every 6 months. So every time you go to the dentist, exercise your breakers. Once every 6 months to make sure that internal mechanism is staying pliable. But because of the exterior condition of this breaker and the different evidences we're seeing of exposure to moisture, and that was one of the big things in this report. Lots of moisture evidence in the basement, including mold. And I would be incredibly suspect that that breaker would perform suitably under a fault condition because of the high moisture condition. So at the very least, exercise your breakers. And in this case, we replaced the panel and all the breakers and just freshened everything up in a big way.
I'd never heard that every 6 months. That's an easy rule of thumb. Every time you go to the dentist, exercise your breakers.
That's your Google Calendar reminder.
Yeah, and in this house, both of the floor drains in the basement were clogged when we bought it, so it was not draining. Obviously, no dehumidification or anything going on. Plenty of, it wasn't totally airtight even. You can see some light through some of those like boarded up windows and things like that, so it doesn't surprise me at all that moisture could have been playing a role. Now we've got a dehumidifier running down there. We've gotten those floor drains opened up, and the next project of many will be kind of sealing up the walls, getting some probably insulation foam in there, and yeah, so all those things will be improving here, but we've replaced all these components.
That's great
as well.
The electrical system really is going to have the best life and provide the best service if the moisture content is between 30 and 50% humidity, and it's really consistently climatized. That's going to serve the breakers well. All right, here we've got the bottom of the electrical panel and an open knockout, so that everything's required to be fully sealed. Knockout closers for all different sizes, whether it's this 1/2 inch, 3/4 inch, and then these concentric knockouts here, 1 1/4 inch, 1.5 2 inch, 2.5 inch. Knockout closures are designed, sold at every local hardware store for that purpose, so that it gets sealed back up. It's going to prevent the infiltration of mice, rats, bugs. It's going to prevent accidental entry of something into the panel that creates a shock hazard for personnel. It's also going to continue and carry the fire rating of that enclosure. And so the knockout closure is required to be of the same material, thickness, and type as the panel itself. So you'll see that those closures are designed with, they're a little bit beefy, and we'll close that up properly. Now here's an interesting debate right here. The electrical service to this property appear to be rated at less than 200 amps. Yes, indeed, 100 amp rated. You can tell by wire size, pipe size, meter size, that is all sized and rated to 100 amps. A thought process around that real quick on a couple different fronts. One, from a cost equation, the cost of upgrading the electrical panel only from a dated 100 with evidence of corrosion to a brand new 100 amp panel, sitting in the range of anywhere from $500 to $1,500, depending on a lot of different factors. The cost of upgrading the entire electrical service from 100 to 200 amps does require, and a lot of people get this confused. I hear homeowners say all the time, hey, my inspector said I've got a 100 amp meter. What would it take to get a 200 amp meter? That's actually not the question. You need a 200 amp service. That means everything from the point of utility connection all the way through the distribution system and into the main panel. Absolutely everything is required to be 200 amp rated. The size of the pipe, the size of the wire, the size of the meter. You can't just swap out the meter itself. In fact, the utility company will probably utilize the same meter. It's the whole service. So the cost of a service upgrade in full, you're looking at typically between $1,500 and $3,500. So tack on another $2,000 to that project cost. And in this case, we've got a couple unique situations in that this gets even more involved and runs that price up because this service is grandfathered in for the time being while it remains in its present location. But when it's upgraded, it's got to comply with the present standard, utility standard, which is 3 feet, in the case of our utility, 3 feet to edges and corners, 3 feet to operable portions of windows. This is not a 6-foot wall space. So this whole electrical service has to be relocated if it's upgraded. And now we're in that $3,000, $3,500 range because we're relocating this wiring and extending its length to a totally other part of the house. And really, in your situation, Tim, that was the ideal location for that service.
Yeah, we had that exact conversation with Andy from Jefferson Electric, was our lead electrician. He said, look, I know you came from 200 amps because we had been in a new home previously, so this was another one of those kinds of, we're actually giving something up for a little more space, and so we were talking about, should we get a new panel just to make sure we're kind of ready for the future if that becomes a necessity? And he pointed out, nope, we'd have to change this and this and this and this and this and this and this all the way through the system, the whole service. And so he recommended, he said, probably best to save money here, especially if you're spending money on new floors and the whole house rewire anyway, and some of these structural issues and the landscaping, these things that you want to do, probably better to hang on to this one for later and just kind of trust that the things that we'll do in the house will massively increase longevity, and then you can figure these things out when you're back flush with cash again, if that ever happens.
That's it. And you know, replacing the 100 amp panel that sits in the basement just inside that point is really not going to cause you any backtracking at a future date, because that can become, instead of a 100 amp main panel, a sub panel, such that you don't have to relocate that panel, you don't have to pull out all the circuits and reland them. You could have a 200 amp main panel at another location or adjacent to that. So really the decision you made didn't cause any backtracking. Let's talk about capacity for a minute here, right? So you don't have 200, we've got 100. Is that sufficient for carrying the house? And your house is how many square feet?
Close to 3,000.
3,000 square feet, 100 amp. I see home inspectors all the time that say, somewhat dogmatically, 100 amp service is underrated for the size of the house. Gets a little bit complicated. National Electrical Code Article 220 is service, feeder, and load calculations. There's a scientific and systematic code compliant manner to calculate the required capacity of this house. It includes the square footage of the house. It includes the appliances and circuits that are present. You've got to consider everything: electric oven, gas oven, hot tub, electric vehicle, furnace, AC, all of these things. Typically speaking, the average homeowner with a 3,000 square foot house, where the major appliances, or most of, particularly heat, are gas, the rule of thumb is you're coming in under 100 amps on your load calculation, and you can safely and suitably operate the house on a 100 amp service. And that's the case in your case, Tim. One of the things that also informs this decision is that your garage is detached. And so one of the biggest consumers of electricity right now that we're all experiencing are electric vehicles. That's going to be a 30 to 60 amp continuous load. That's going to be a massive draw. Think of a 60 amp continuous load on a 100 amp service. 60% of your available capacity for one purpose. Well, in your case, because you've got a detached garage, you can actually get a utility drop, separate power to the garage for the purpose of electric vehicle charging alone, and you can mitigate putting any of that capacity on your main electrical service. So let's say in 5 to 10 years, you and your wife, maybe less, are driving all electric. You can drop a 125 amp electrical service to the garage. You can charge 2 Teslas, for instance, at the full rate without exceeding the parameters of that electrical service. And you can mitigate putting any of that load on the house and avoiding that expense and upgrade at that time. So there's more than one way to skin this cat. And at this point, that's a future problem. But at least it's not a code issue, and the house is properly serviced.
Super.
Plumbing and fuel systems, not our problem.
Yellow cable, orange cable. There's even a clamp to some metal piping here. Like, I think that's a water pipe. Is it okay to ground to that? And how do I keep straight? I think there's also some data cables. Like, I think this was an old cable wire running up here. It's maybe too many questions at once, but.
Okay, yeah. Well, let's a quick review here. So this orange wire here, that's going to be your 10 gauge. That's going to be to appliances like water heaters, dryers, things of that nature. We've got 12 gauge up here, but that's signified by the color yellow. I believe this looks like a 14 gauge. We can call that number 14 right here, that white. And so that is a universally present across manufacturers color coding for wiring systems at this point. I love the fact that it looks like the 14 gauge is terminated to this open terminal block, like totally uncovered, exposed, and live energized electricity that is like super convenient for making quick electrical connections and incredibly hazardous. So that's a ton of fun right there. The clamping system that you referred to here is interesting, and grounding and bonding is the single most complicated, even above and beyond service calculations, the single most complicated and debated and misunderstood code articles of the National Electrical Code. It's an old-fashioned method for routing the bonding conductor. It's not commonly utilized in residences today. Is to use a metallic, either rigid or EMT conduit like this that terminates in a threaded hub fitting that then there's a continuous copper strap right there. It's hard to see in this photo, and it culminates in this clamp, which is not connected. It's just floating right there. And it's intended, very intentionally and most importantly, to provide a safe grounding and bonding path from the gas piping system and any metallic domestic piping system, if it's gas, if it's water. I don't know what else there might be. If it would be a central vacuum system, which is typically PVC, but maybe there's some metallic systems out there. It's important that every domestic piping system is bonded to the electrical ground so that if it were to become energized, it will safely dissipate that current to the electrical grounding system. So it's not energizing the piping system, it's dissipating fault current. Let me tell you a quick story. It's a true story. One of our customers, good long-standing customer, his nephew, when he was about 8 years old, was with a group of friends, and he knelt down on the ground, one knee to the ground. That ended up being the grounding path in this unfortunate circumstance. One knee to the ground, one hand on the metal hose bib, just an old-fashioned metallic everyday hose bib. And because that metallic piping system was not bonded to the electrical system, it actually was energized with some neutral current flowing through there. And when that 8-year-old completed the circuit to ground, hand through the heart to earth, that current exited his knee. He actually did not die in this case from electrical shock. He passed away from positional asphyxiation. He was caught by the current. He was frozen in place, could not move. And his friends were all standing there watching as the story goes and panicking, knowing that something's terribly wrong here. And they ran and got their parents and came back. And by the time they got back, the child had passed away because he was fixed in place and literally was asphyxiated by his inability to move and free himself from that current. Solution in that case would have been a dive tackle from one of his friends, such that they cleared their ground path. They jumped off the ground and tackled him and knocked him out of place. He probably would have been completely fine, or taken some non-conductive object, a board, a stick, a trash can, and just knocked him off and freed him from that electrical current. But of course, they had no idea what was taking place and didn't know that that was the solution. So that's what this is going on right here. See that? That clamp has come loose from the gas piping system, such that if someone were to contact that gas piping system, if it were energized, and part of what's deadly in this situation is if it's ungrounded, if it's an ungrounded conductor, hot conductor, that's energized to a gas piping system, it'll typically fault and the breaker will open. But if it's neutral current, then effectively we've just created another path for the current. Like we say, electricity does not take the path of least resistance. It primarily takes the path of least resistance, but it takes all paths. And that gas piping system could readily become one of those paths. So it's real important that that is continuous, that bonding connection to the gas, any metallic piping system back to the main electrical panel for safety. One of the things that electrical contractors will typically exclude from their scope of work is low voltage. Low voltage would be anything that's 50 volts or below. You can get a little sting in a ring off like 24 volts or 48 volts. It's not going to kill you, but this Cat 5, white Cat 5 cable that runs through the picture right there, that is probably not going to be included in the scope of work. It is a slightly different skill set. A lot of electricians will possess that skill set. I would say some possess that skill set, but there's a different thought process to how that cable's run. It's a different cable type, a different tooling required to make those terminations. And so as a homeowner, that's non-hazardous as long as you've properly identified it as a low voltage system. And you can cut out those old cables, route new cables. Usually those kinds of things turn over with occupancy, because now your TV's in a new place, you need the cables in a new place, your workstation, your office, your desk, all those things, which are typically at this point wirelessly connected, become dated pretty quickly.
That's good for me to know. I haven't taken them out yet, but we have maybe one or two streaming services, but no cable. We've got internet, but I know very well where that fiber cable is running, so right. I know that this one is not used by us at all, so it may come out because it's kind of a mess. It's hanging really low, it's in the way.
Yeah, you can take your pliers and just cut it out. Again, as long as you're certain it's 50 volts or below.
Yes, yes, yes.
Let's talk about a couple things that kind of distinguish, in my opinion, home inspectors. We say all the time to frustrated homeowners who have just purchased a house and now are facing some substantial repairs that they did not anticipate, right? They spent $500 on a professional home inspection, and at this point we've come in because a little bit of knob and tube was detected in the attic, and they're like, yeah, let's go ahead with the transaction. They purchased the home, and we come in and present them with a $12,000 estimate to get rid of that little bit of knob and tube. That's one, for instance, that happens frequently in some of these older parts of town that we work in. And the case there is knob and tube is extensive. It's spiderous, if I can use that word. And I would say, pest exterminators say for every one mouse that you see, there are 20 more behind the scenes. Knob and tube is like that. For every bit of knob and tube you see, there is 20x behind the scenes because it's typically concealed behind finished surfaces. Home inspectors will not remove cover plates to check receptacles and switches. They'll use a plug-in check, which they should and they do, to check a receptacle to see if it's properly grounded or if there's reverse polarity, the switching of hot and neutral conductors at the receptacle, because it's a polarized device with polarized connections. They'll do that. But the hack here is, if you want to identify knob and tube in particular, which we had in this situation, go to what would be the most difficult part of the house to rewire. Like if you've got a 2-story home, the ceiling of the first floor is the hardest part to rewire because it's incredibly invasive. You've got to cut and drill through the finished surface. You've got to fish. It's very time consuming, which means expensive to replace that wiring. So go to your dining room on the first floor, your living room, your kitchen. Take the cover plates off and look for that old knob and tube wiring. You can find pictures online readily. And if knob and tube is present there, now you're talking, you're immediately in the ballpark of thousands of dollars, not hundreds of dollars, to replace that knob and tube. So if a little bit of knob and tube is ever detected, and that's all the inspector calls out, just know that they're stopping short of a complete electrical connection. I typically am impressed with home inspectors and the variety of things that they're able to catch and the diversity of trades that they're able to operate effectively across, but they're not providing a complete electrical inspection that would be on par with what an electrician would provide. So that's recommendation number one. A little bit of knob and tube, get a pro in there, pop those cover plates off, take a look. You're not gonna remove the finished surface of the wall, right? No one's tearing down drywall to check for this stuff, but the thing is you don't have to. It's more evident and readily visible than that. One of the things I'm looking for in my inspector is I want to be present when the inspection's taking place, and I want to see him physically get in the crawl spaces and crawl around, get in the attic and walk around, right? A lot of inspectors, unfortunately, will kind of pop their head in, shine a light, look around, and that's it. You're not going to get maybe the depth of rigor that you're looking for out of 50% of the inspectors out there, so that's always question that I'm asking. And then,
and just like you said, like with the knob and tube, it's generally in the hardest to reach places. So it pays. It pays.
What else? How else are inspectors? Do we cover the technical? Do we need to?
Yeah. What about on paper? Generally, inspectors have these kinds of markings. I mean, they vary like crazy between different inspectors, but it's a necessary, life-saving operation. It's a structural and important thing, or it's something optional to look into.
One thing to note here real quick is the symbology that's utilized by the inspector. In the table of contents, he calls out what each one of these represents. And here, this red cross, we've got a major safety hazard. This is repair, replace, this little hammer here, and that is an item to monitor or evaluate. And so it kind of gives a scale as to the significance and urgency of the situation that's present. And I would say typically home inspectors do a pretty good job, particularly in an older home. A lot of deals fall through because homeowners who've never lived in an older home aren't familiar with or expecting to get 40, 50, 60 items on an inspection report, and they get scared away and the deal falls through. And so being able to scale the sense of importance and urgency, I think is a really good tool that home inspectors are utilizing well. I'm proud of them for that.
That was kind of a thing in our situation, because coming from a new built home, but my wife being in real estate was a nice controlling, leveling factor for me when we got whatever this document is, some 40 pages of pictures and comments and the varying scales of importance. She kind of said, yeah, seems about right.
That's it.
And we made sure to get a price on the home that would allow us to do the repairs we needed to, and then maybe some more if that was what was in our mindset, and it worked out great for us.
Right? Yeah, maintaining a budget, a contingency budget on a remodel like this of probably 15% is not at all unreasonable. Do you have a contingency budget that you utilized?
We did. Yeah. It was all things considered. So we itemized it, like we're talking about here. The electrical, we knew it was going to be a big old chunk. Plumbing was actually in pretty great shape because someone had updated most of it to PEX piping throughout the house. So we were thankful that we could save some money there. And then there were a couple pretty major structural issues. The landscaping, like I mentioned, I think it all came out to maybe it was 70 to 80, somewhere in that. $70,000 to $80,000.
Yeah, that's great
in that range.
For a whole house remodel and a heavy lift like this, and the house of your dreams.
Yes.
Right?
Yes.
Fantastic. Your house is appreciating so quickly right now, given where it's located. That was a really good, smart buy.
Yeah.
All right, let's talk about real quick two things. One, what people can expect to spend on electrical repairs of this nature and a whole house rewire, and some baselines around that. And then two, also differentiators about an electrician, how to find an electrician, what makes a good electrician, what makes a good fit at the right time with an electrical contractor. And so first, on a house like this, I'll give you kind of we do a price builder, right? There's a unit cost that then we scale across the entire house. And so we assess the situation, the obstacles, challenges associated with that situation. We'll assign a unit cost to a device, like a receptacle or a switch, and the cost of rewiring that, all in materials and labor. And then we'll scale that. If there are 85 of those devices around the house, it's that unit cost times 85. And what that does for a homeowner is it allows you to make a tactical decisions as things go along. Hey, if we want to add an outlet here, instead of how much is it going to cost, you know what the cost is. There's transparency in the pricing structure, which insulates a homeowner from paying 125 cents on the dollar or 200 cents on the dollar for an additive change order, and the contractor from providing value at 50 cents on the dollar for a deductive change order, right? There's pricing transparency. So that's one thing that I'm looking for in any contractor relationship is pricing transparency. Some contractors, in fact, quite a few, don't want that because they're going to come in low and then they're going to change order you high, and they're literally could double the budget on a project. And so that pricing transparency is going to be, for me, really important with any contractor. If you've got a one-story home with basement or crawl space access that's unfinished and attic access, you could probably expect to spend something like $100 to $150 per device. If you've got a two-story home with access above and below, you're probably in the $200 to $300 a device range. So let's break it down real quick. You've got a bedroom, 4 receptacles, a switch and a light. That's 6 devices, and that's a really weird way to do 6. So let's break it down real quick. You've got a bedroom. Your average bedroom is going to have 4 receptacles, a switch, a light, and a smoke detector, and a closet light, right? 8 devices. And you're at $200 a device, 8 devices. You're at $1,600 for material and labors to rewire that whole bedroom, start from fresh. We'll exclude lighting fixtures, so it's important to have a list of exclusions in the contract. The homeowner, you and your wife, make decorative lighting choices that will be commensurate with your overall aesthetic. So we exclude decorative fixtures, but we'll include code mandatory things like smoke detectors, all the switches, outlets, cover plates, again, all labor and materials to wrap around that besides what's decorative. Cost for upgrades, like instead of standard switches and devices, maybe a homeowner wants decorator devices, and so we'll just cost that on through with a small markup for the extra effort, inventory purchasing, things of that nature. And then we'll itemize separate and distinct line items. So on your invoice, Tim, you saw a separate actually on the estimate right up front, a separate cost for electrical permits and things like that that would live separately from the work performance itself. I think it's reasonable to expect that the less access there is to the rewiring of a house, let's say the house is 2 stories, but instead of sitting on an unfinished basement, it's sitting on either a finished basement or on slab. Because of the difficulty of that rewire, that's going to escalate your cost substantially. Or let's say it's a mid-century modern house and there's not an attic or not a traversable or accessible attic, that's also going to escalate that cost relatively substantially. So it's not uncommon for a house like this, 2-story home, 3,000 square feet, all in, to be anywhere from $15,000 to $25,000 on a whole house rewire project. One of the things that I always advise people, because our customers will come to us and they'll ask for, hey, do you have a recommendation on a plumber? Do you have a recommendation on a painter, right? And one of the things I'll always tell people is you want to catch the right contractor at the right time. Construction has its seasonalities, so it's a lot higher. It's a lot higher and harder to hire a contractor in Indiana, spring, summer, and fall, because guys are slammed. They're insufficient skilled tradesmen as it is, and then trying to hire them at peak times, there is more cost associated with that. Homeowners usually want to keep their projects on track and pay the cost, and it just is what it is. But then if you can hire someone or even at least get them contracted during an off-peak time or whenever their work volume happens to be a little bit lower, they'll usually come in a little bit tighter, rider, and more aggressive on that price. And so that's a really strategic aspect from a homeowner standpoint of hiring a contractor. And you know, everybody kind of recognizes that there are multiple work divisions. So if you're doing a residential rehab, you don't want to hire an industrial contractor. They're not tooled and skilled and experienced in the right manners and methods for a residential rewire. That's well recognized. You've got industrial, commercial, and residential. And typically the industrial guys are charging the most, and they have a really finely tuned skill set. And then the commercial and the residential trades people tend to be more cost effective. But even within an industry category like residential electrician, you've got various types of specializations. You've got the people who are familiar with older homes, the ones that just do service work, the ones that just do new construction, the ones that do renewables. There are separate and distinct, again, experience, tool sets, skill sets that go along with each one of these. So you want to try to capture a contractor, if you want the best outcomes and experience and pricing, capture a contractor that specializes in the specific subcategory of your choice. And I think that's a really valid question to ask. What's your familiarity with rewiring older homes? And that's potentially a $4,000 question on a whole house rewire.
All those things came into play in our project as well. So by closing in March, we did okay finding all of our contractors.
Fantastic.
We also had a lot of personal connections, mainly through our church. We had lots of tradesmen, and so those are great connections to start with because we trusted those people and their work ethic then, and then we assumed that the skills would follow. And then, based on the order of the project itself, being able to communicate upfront, like you talked about pricing too. So we were going to do the demolition ourselves. So now once the upstairs is no longer finished, because we had blown out several walls and ripped off a lot of like plaster and lath that was going to be replaced with simpler drywall, now we could have Jefferson Electric come in and they're treating it as new work instead of remodel work and having to be careful around all of our finishes and things like that. So we tried to plan all of that ahead of time. Jefferson coordinated with our contractor so that they were in and out at the right times and made everything easier for everyone and was cheaper for us as well. It was great.
Right, and you're making a really good point there, Tim. One of the best things that you can do as a homeowner is anticipate opening up some of the walls. So the trade-off here is you don't want to open up all the walls because you incur demo costs and then also finishing costs. But if you can open up the strategic walls for HVAC, plumbing, electrical, the skilled trades, you're going to substantially expedite their progress. And those are the key walls. Typically it's bathroom walls, kitchen walls, and then a couple of stacked walls, first floor, second floor, so that mechanical chase can be created from basement to attic, things of that nature. And you guys did a good job of that. And again, we were able to offer a pricing break in that respect. So that's a really strategic thing to anticipate doing as a cost-saving measure. So if there are code violations that you spotted that we didn't cover, hey, engage us in the comments below. Or if you've got electrical concerns and violations that have popped up in your inspection report, comment below. We'd be happy to help you out. In our next video, we're going to cover what the heck is this, and why should your electrician stock it on his truck, and why should it be in your home.